Good evening, morning or afternoon, ladies or gentlemen. Welcome to this video. By the title of the video, you've probably already seen that this is about my thoughts on Node.js and Deno. I have recently worked a lot in both of them, Node.js professionally for years now. To give you some context, I am fairly experienced, but obviously I'm still young. I'm fairly fresh out of university. I'm a fairly junior developer, but I like to think I know what I'm doing, and I've used Node.js a lot. And in a personal project, I've recently started using Deno. And when Deno came out, I felt like there was this huge hype that emerged about this new JavaScript runtime and what that meant for running JavaScript, and was this going to revolutionize JavaScript programming out of the browser? And the simple answer was no, and I think that left a lot of people disappointed in Deno because it didn't outperform Node in terms of a computations per second, CPU clock, whatever kind of way. It just kind of matched it, and it didn't bring any new functionality that didn't already exist in Node, or at least hadn't been kind of shimmed into Node, and I'll get onto that in a second. And so, for those reasons, I think people kind of dismissed Deno, and I dismissed Deno as well. But on some projects that I've been working on recently, I felt like I was really enlightened to just how great Deno actually is, and so I thought I would make this video to kind of try and communicate my thoughts and my understandings so that it may help any of you make a more informed decision about whether to use Node.js or Deno in the future. So, to give you some context to how I've been working on Node and Deno, I will swap over to screen and webcam here and show you some GitHub repositories. So these were a couple of little projects that I built. This one, Fastify Preact SSR, is exactly what it sounds like. Sorry, I just drank coffee, I'm still swallowing it. It's exactly what it sounds like. It's essentially Fastify, which is a Node.js web server framework, Preact, which is essentially React, the front-end JavaScript library, but smaller, built to run faster. It's essentially a clone of React, just designed to be as optimal as possible. And SSR standing for server-side rendering. So this was basically a web server that would take Preact source code, which we can see in the source folder here. It would basically run that Preact code to generate the HTML for a page on the server side on each request to the web server, so that it could deliver the user pre-rendered HTML before the user then takes that same Preact JavaScript and runs it in their browser to hydrate the page. So that's what server-side rendering is. And there are a few reasons why server-side rendering is popular. It essentially helps you get 100, 100, 100, 100 lighthouse score like this. And if you were just using a standard create React app or such without server-side rendering your JavaScript to HTML first, you might not get 100 on SEO or potentially performance maybe, because when the page loads, you've initially got a white page, the JavaScript has to run, then it populates the page, and it also means that there's no content in the HTML for search engine crawlers to find. Basically, your HTML is blank before the JavaScript runs, whereas with server-side rendering, it is not. So that's basically a quick overview of server-side rendering. And so I got really into the idea of server-side rendering Preact just as like a hobby project, and I was considering using it for a few kind of website ideas that I had in mind. And yeah, I hadn't tried Preact before, but I'd heard a lot about it. Hadn't tried Fastify before, I'd heard a lot about it, so I wanted to just experiment. So I made this project here, posted it on the Node subreddit, and it was fairly well received, 32 stars. And so server-side rendering Preact is obviously something people are interested in, and obviously you get great performance benefits. And shout out to Kyle McQuarrie. I actually read his blog post along with a blog post on DigitalOcean, and they really helped me get this set up and running. But let me take you back in time to when I started this project, and I thought, okay, Node.js supports ES modules, browsers support ES modules, so I should be able to write JavaScript code that can run on the server and in the browser at the same time, right? That would be cool. And then I can just have my source repository of my Preact components and pages and such, and when I want to server-side render them, I just import those JavaScript files on the server and run them, and then when I want to send them to the client for client-side hydration, the client can fetch the exact same source files and run them in the browser side and hydrate the page, right? That would be awesome. Well, the reality is, no. Even though Node.js does support ES modules, it doesn't quite support them. Well, it does support them, but there are reasons why that doesn't work in Node.js. I won't go into the reasons right now, otherwise this video will become super long, but if you want to check it out, go to this repository, it's public, and check out the pure ESM branch here. This is where I tried desperately to make this work, and it did not work. The long story was that I had to use Rollup, and Rollup is a web bundler tool, and it will essentially take, in this case, the source JavaScript modules for the Preact front-end application, and it would roll up a server-side bundle and a client-side bundle that was separate. And so when I wanted to server-side render the Preact, Rollup would have generated me a server-friendly and Node.js-friendly Preact bundle at build time of the application. So when I start the application, I run Rollup, and, well, I think I was actually having to run Rollup as my default kind of like server start command. Rollup would be like called on each server start basically to generate a fresh server and client bundle. And so the server bundle would use CommonJS, which was the Node import method, and the browser bundle would use ES modules. And you may be thinking, oh, but you just said Node.js supported ES modules, so why are we using CommonJS in the browser version? And that is a very good question. The short answer for that really is that CommonJS modules have historically more support in Node. That's what Node was built for. I tried it with ES modules and it just didn't quite work. I'm not entirely sure why, but because that bundling was happening behind the scenes to me. This bundle would come out quite garbled and it would be difficult to read through essentially. So when it doesn't work, it's quite difficult to debug exactly what's going on there. So I stuck to CommonJS for the server-side bundle, and it was fine. It worked. And so there I had Preact source code with, you know, like blah 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 components, etc. Yeah, like that was fine. But I still just had this itch in my mind from when I had first started this repository and built this project for the first time, that I just wanted pure ESM, and having to roll up my source code into separate bundles felt like a kind of just a painful, unnecessary step when I knew that Node.js supported ES modules, and obviously so did browsers. And what it really came down to was that in Node.js, when you import a module, you can say import React from React and just React in quote marks, and the Node.js runtime will take that React and it will look through your Node modules folder for React and it will import the default import from there. But browsers can't do that. When a browser sees import React from quotation React, it's just looking for a file path. And React as a string is not a file path. That means absolutely nothing to your browser. And that was ultimately the reason why the JavaScript that ran on the server couldn't run on the client, and if in the browser, sorry. And if I changed it so that it would run on the browser, then I would have to like put kind of try and restructure the back end so that the link, so that the path in the browser would also work as a path on the server, which seems like it might work, and I tried it. I believe you me, I tried it here, and it wasn't going to work. I then tried to use import maps, but import maps would kind of solve this. An import map essentially would be a file that you could give the browser, and when someone says import React from React in JavaScript, or import whatever from whatever, the import map stores these names, so just React as a string, and then it says what's the actual path to import that from. So then the browser can reference the import map and find out, okay, import React from React, that actually means import React from /source files /react /dist /index.js, whatever. The only problem with import maps is only Chrome currently supports them. So, I mean, Chrome's got a lot of users, sure, but I think no one would make a website that just supported Chrome. Polyfilling an import map as well is just a headache. And so you can see how, going down this road, I was basically having to give up on the pure ESM dream and stick to just using rollup, which was fine. It was fine, and it worked, and people liked it. And if you want to run Fastify Preact server-side rendered with a Fastify web server in a Node environment, then please be my guest. Take this repository. It works, and yeah. But like I was saying, I still had this kind of this itching, and I'd heard about Deno, and I had been in the place I was explaining earlier of kind of like, I don't know, knowing that Deno was there, knowing that it offered some security benefits, knowing that it natively supported TypeScript, but you know, when you've got rollup running on your code anyway, then supporting TypeScript is just basically putting a Babel plugin in your rollup that will just run some Babel transpilation on your code and swap out the JSX or the TypeScript types, sorry, and JSX as well, whatever, it will swap that out when it bundles. And so if you're already using rollup, then is it a big difference really to use Babel as well? And then if you're using rollup and Babel, and suddenly you're pulling all of these tools in, combine that with the fact that the Node.js runtime is kind of built around this idea of using lots of node modules. So before you know it, you've got hundreds of node modules. You try and containerize this thing, bundle it into an image, and you've got like a gigabyte image for just a simple website, and you just think, what? How has this happened? You know? Anyway, sorry, I got distracted. And so I'd heard about Deno, and I had been really trying to solve this problem of, okay, Deno isn't, I cannot share my ES modules between the browser and the server in Node.js. Let's check out Deno, and let's just see what happens. So I checked out Deno, and believe it or not, an absolute miracle unfolded before my eyes. Deno is built and designed around the idea of using URL-based imports in your Deno code. And so when you import some whatever, a page component, some kind of library of some kind, whatever, into your Deno application, you don't download it as a Node module first and then reference it as a Node module. You just reference the URL where that will be found, and Deno behind the scenes will cache all of the URL dependencies that it finds in your code base, so that you're not pulling them every single time. Deno installed on the machine actually kind of keeps a store of the dependencies that you've pulled, and I don't know if it cleans them up behind the scenes when you stop using them and stuff like that. I'm sure it does. But basically what that means is you can have JavaScript that is written to work on the web with a URL import, you know, import Lodash from unpkg.com, whatever, /Lodash, and reference that in the JavaScript, just like a kind of CDN style import that you may be used to using in the browser if you've ever done something like that. Deno is built around that. It's built to match that, and not only is it built to match that, it's built to match basically all of the web API specification stuff. So like the WebSocket class or type, the HTTP response type, you know, the headers type, all of this stuff is basically designed to match the browser specification. And I can't bash Node for not having that, because Node was built, I think, before a lot of this stuff existed. So the Node community and the Node development team kind of had to take Node in a direction and build upon it before browsers were really, you know, like at this level even. And so Node probably helped progress browsers in a way by kind of like competing and pushing the boat out. But browsers eventually created their specification, distributed that, all built their JavaScript runtimes around this specification, and that it just kind of diverged from Node. And that is exactly why when you try and run JavaScript on a browser and on a Node server, you're going to have to use something like Rollup, even with ES module support, because it's just not quite the same. Whereas Deno has been made to be as identical as possible to the browser JavaScript runtime, and it basically has complete support for everything apart from you can't access like the window or the document object, because obviously there is no window, there's no GUI, you're not in a browser, you're on a server, so understandable. And so with that knowledge, I went ahead and started trying to recreate this project in Deno, and I have ended up here with Pecco, which I got the whole chicken vibe because it's featherweight, because we don't need Babel, we don't need Rollup, we don't need any build time technologies. Literally, you run the server references the source code for server-side rendering, the server sends an HTML file that references the source code as well. I've actually got some bundling happening in here currently, which is just for if you deploy to production, it makes more sense to bundle the file for the page that you're on. So if we go to home, you can see I'm importing some Preact functions and I'm importing a layout component. If I just reference this directly in the browser, it's gonna reference this, and then it's going to be like, oh, okay, I also need to import this, and I also need to import this. So these would be separate network requests, which is great in development because you see all of your files as they are in your source code. And if you get an error in one of those files, it's exactly the same line that it would be in your source code, and debugging is a dream. But in production, having those like that cascade of requests is just suboptimal and a bit slower. And so I've got bundling still in this project, but it's just using the Deno runtime bundler, and it only runs if you're in a production environment. And that will just serve bundled JavaScript files for each page. But essentially, there's no build time technology. Even that bundling, like I said, is part of the Deno runtime, meaning there's no external bundle library that's bringing in tons of other dependencies coming in. This is essentially dependency-less, apart from obviously Preact, which is running the front end. And currently I think I've got Denon. Yeah, if you're developing, then you'll install Denon on your machine, but that's not needed in production deployment, and that's not built into any Docker files or images that you would build. And so you end up with images that are like less than 100 megabytes big because you're using Preact and you've got bundling. This is before code minification and anything like that. The JavaScript files are already like 25 kilobytes. So it's absolutely, I feel like I've reached what I set out for basically with this project. And yeah, this was like the first stepping stone on Node that led me to Deno to recreate it, and Deno was the perfect environment, JavaScript environment for this. And then all of the other bonuses of Deno really start to come into play once I had discovered this kind of big value in that, like, oh great, it uses URL-based imports and I can use browser JavaScript files in Deno with no problem. Then it was like, okay, well, what other benefits have we got? We've got native TypeScript support, which means I don't need to use a transpiler to run TypeScript. That's absolutely fantastic. And you might think, well, what about JSX? But we've got this fantastic library made by a developer called HTM. Let me see. I think I've got a link to it here. Here we go. Which essentially lets you, here you go, lets you declare HTML through a tagged template literal in JavaScript, meaning that you have no JSX. If you don't know what JSX is, it's a type of markup language that you can write in JavaScript. React has been based upon the idea of using JSX really for a long time now. However, if you run that JSX, if you run a JavaScript file with JSX in it, it will break because there's no machines, browsers or servers, neither of them can actually compile and run JSX. So you kind of just have JSX in your code when you're developing it, but when you actually run it, your code transpiler and your bundler like Webpack and Rollup would use Babel for code transpilation, and they would get rid of the JSX. But if you use HTM, you can just essentially use JSX-like syntax, but you're actually writing it in HTML format as well, so it's a bit closer to home, which is nice. It also means you can take HTML snippets from any site anywhere and put that into your JavaScript code, and it's going to work beautifully. And then this is completely browser friendly as well, so you don't need to transpile this out. You can just send it straight to the browser and the browser can run it. And so we've essentially achieved complete server and browser synergy and cooperation, which just feels lovely, and really it's all because of Deno. So I mean, yeah, there you go. That's basically my 2 cents on why I think Deno is great and why I understand how it's not more optimal. You know, it's not faster. It doesn't like 10x the state of the art compared to Node. It's pretty comparable to Node, really, at the end of the day. But there are many subtle and less subtle differences. And when one of those differences makes a big difference, like it has in this project, you really notice it. On top of that, I just feel like Deno has really been built with like a beginner-friendly community in mind, which I personally really love. And I love the idea of the internet being open for people to come and experiment with, and you know, hiding functionality between walls of knowledge and needing to know about JavaScript bundlers and transpilers and everything to properly understand how your server-side rendering application works. It's just a whole extra step of logic to wrap your head around and then also maintain and look after. Whereas being able to scrap that, absolutely massive. And what Deno is doing with Deno Deploy as well, to just try and kind of just open up coding to the beginner community and make it easy for people to get code running online, is really cool as well. So I like the vibe of Deno. I really appreciate the features that have been built into the Deno runtime, and now that I feel like I've kind of seen the light in a way, I'm really probably going to prioritize using Deno over using Node. And yeah, I mean, that's not to say that I think Node is bad. Node is obviously absolutely amazing, dominates the JavaScript like world at the moment, and probably will do for a while. And to all you Node developers, keep smashing it, because Node rocks, but Deno rocks too. And so that basically wraps this video up. If you want to check out this repository, the link's obviously here. I will put this in the description, and feel free to use this. It's not quite production ready yet. There's a couple of kinks that need to be worked out basically, but it's getting there. So thank you. Leave a comment if you like the video. Let me know any thoughts, that if this is interesting in any way, or any reasons why you like Deno, or any reasons actually why you prefer Node to Deno. That would be interesting to hear. Subscribe if you fancy it, because I'm probably going to be posting more of these videos. And yeah, rock on.